Good evening, everybody. Welcome to the warm early spring weather desert of Eastern California. My name is Mike Jerry, and starting a few minutes early tonight, but I'm up and ready to go, so why not? Let me turn this off so I'm not feedbacking on myself. Okay, tonight we're going to have the February Observer's Challenge from Cloudy Nights. And in fact, since I'm a couple minutes early, I guess I have time to make up to do this, because I need to load the list for tonight, which I did make earlier, but then forgot to bring it on here. Astro Pics, Observation List, Cloudy Nights, Observer, February 2025. Okay, highlight all. And go away. Alright. And there's all our little objects right there. Okay. We've already got a couple that have gone across to the west side. Oh, that's alright. Well, I think we'll stay off the west side as much as we can, just because it's we catch a lot of satellites. So, anyway, tonight, and I guess I better turn off the test pattern so you can actually see what I'm seeing, but there we go. All our little circles here of objects that we're going to be getting tonight, and I guess I should go over to the other side and pick them off one at a time. I don't like being on the west side of the meridian this early in the evening, because we tend to catch a lot of satellites in the early sun. So I may, well, we're so close to one of them, I may just steal it right now. In any event, the first thing I need to do is show you my setup. So here is what we are, here's what's bringing us the images tonight. This is a Celestron 8-inch Schmidt-Cassegrain telescope with a Arizona Hyperstar stuck on the front, and the camera stuck on the front of that, and that is being swung around the sky on ZWO AM5 mount, and I'm sitting at a table behind here talking to you. And so that is what's going to bring us our images tonight, and it's on, of course, my spare no expense cinder block pier, which you regulars know all about, so I won't go further into that right now. Let's see if we can get 2371. It's a nebula. Oh, it's a very faint nebula, huh? Well, let's see if we can pick it up. Double bubble nebula. Let's just start on our first object, since it's right here next to us. Decisions. Where do I get stuff as they come across? Actually, I think I'm probably better off going across first. Let's just flip the meridian now to stay there. These are a little bit, it's a little bit bright still, so I don't want to, and these are better off. What is this? HP 248, 878. Okay. Yeah, let's go over to that one. Let's flip over the meridian and go to that one. Okay, we are right on the ceiling for this one. Okay. And okay. Let's do our plate solve, which is going to throw me off by 2 degrees. And then I will have to bring it re-slew to bring me back. I don't know why it does this when I flip the meridian, but it does. Bring it right back there. And that should be our object right there. Now, I'm going to get this started. While that's loaded, I'm going to get the challenge up. So we can see which object, because I think this is, I don't remember whether this is Berkeley 17 or if this is one of the, or if this is the Tombaugh object, because they aren't listed in the, they aren't listed. Stellarium doesn't have listings for them, so I had to pick a nearby star. Where are we? There, there, and there. Okay, and so this is, which one? This one's going to be in Auriga, so this is going to be Berkeley 17. This one is going to be Berkeley 17. There. Which should be, it's a very old open cluster. Yeah, one of the oldest known open clusters. Is like 9 billion years old, supposedly. So it's in a bit of a star field, and so it's kind of hard to pick out. But we'll see what we can pick out here. Yeah, see, so I think it's this right here, Berkeley 17. Let's see if the annotation, oh, and I know what I forgot to do. Shoot. We're getting a nice, yeah, so that is it. We're getting a nice big glow in the middle here because I forgot to include my flat. Where's the flat? That one. Okay, and then I need to clear this before the next sub comes in. Alright, now this should look a whole lot better. Okay. Let's change all that up. Get in here. This should now show up. Yeah, so this is about a 9 billion year old cluster of stars, one of the oldest known in the universe, in the Milky Way galaxy. So it's very faint. It's almost hard to tell that it's a cluster at all. We're going to spend a lot of time on it, but it's a pretty cool thing. Stan and Ray, hello, welcome. Do you have or know where to watch a video on setting up the SharpCap sequencer? No, I'm not aware of one. The only thing I could recommend you to is the SharpCap online manual, which does a fairly good job of it, and just really poke around with it. You know, the sequencer basically is it's drag and drop programming. So you drag something from over here and drop it into your growing sequence here, and then when you click on each individual sequence, you can change any of the elements inside the sequence. So it's basically just drag and drop, very simple, high-level programming. So you know, and there's a lot of stuff in here. I mean, when I built my scripts, half these tabs weren't even here. So I should actually go through here and see what's new. I may even find some new tricks. But so here's one of my sequences here that I use. This one is for when I moved on to an object to start the sequencing. So it sets my gain level to where I want it, sets the display histogram back to reset, sets my exposure to what I want it to be, starts the live stacking, and then waits a couple of seconds, and then deletes and resets it. Because if you don't wait a couple seconds, something gets stuck in there. So you know, it's a very high level programming, and it works very well. Honestly, I'm not sure why you're interested in the sequencer, but if it's just to, you know, move around and see other objects the way I do it for EAA, and it's not like for overnight programmed runs and things like that, then I would actually not use the sequencer anymore, I would send you to the go-to catalog, which has an entire sequencer in itself. You can go into the catalog, find your thing, click go, and it automatically does a lot of the same things that my sequences do. But I have been using those since long before the go-to functionality was added by Robin, and I'm just sticking with it because it works well for me. But honestly, if you're just doing the EAA kind of thing that I'm doing, I would send you to this the go-to catalog. Look up in that in the manual, the online manual, and see if that actually does what you want it to do. A lot of people just use this, and they don't use sequences. But I've been using the sequences for so long that they just work well for me. I use them, and I'm used to them, and so they work better for me than the go-to does. But anybody who is just starting out, I would probably just send you the sequencer. Random Erewhon live with C-star 50 and a refractor. Erewhon live with C-star 50. I can't tell what you mean, Ray. If you're live right now with a C-star, or what you're saying there. Stan says, "Can you click on all my tabs so I can screen cap them?" Well, I'm not sure what you mean by all your tabs. Which all my tabs are you meaning? You mean all my tabs in the settings, or all my tabs in the live stacking? It's a lot of tabs, so I'm not really sure which one you mean. Okay, but anyways, you can kind of see that this cluster is here, and it's a really old cluster. Oldest known, I think I read today that it's a 9 billion year old cluster of stars. So it's pretty cool, but it doesn't stand out very much from the background. It's in fact, I don't even know how the heck they found it. Maybe it's just this pocket of really old stars amongst regular stars, and that's how they found it. I'm not sure, because I would cruise right by this certainly. TRO in the sequencer. You want me to go through in the sequencer? Well, these tabs here, you mean? You don't need to screen capture these. These are just all the this is everything that comes with the program. So all this stuff is here. You don't need to screen capture this because you open your SharpCap and you'll get all these. So this is nothing unique to my setup. This all comes with your installation of SharpCap. So you don't need to memorize this. That you don't need to screen capture those. You don't really need those. Random Erewhon YouTube channel. Okay. Alright, so Berkeley 17. So very old cluster, but not a lot to see there. So I think we will move on to what is our next thing. Let's go to the letter Y cluster, NGC 1893. All right. Alright, let's go up to that one. Just a very short little hop, and it's another little star cluster. Okay, so start that imaging. Alright, and let's get that there. Alright, and let's actually start some background music going here. Okay, so this is going to be NGC 1893. What did he write about this? 1893, open cluster, and an emission nebula. Yeah, so it's called the letter Y cluster here. A lot of people call it the tadpoles. This is let's see. Oh, I'm doing it with broadband. So this is the tadpoles. Actually, is pretty cool with a filter because it's in a very deep, a pretty dense sky. It's pretty dense star field, but it's also has reflection nebula in it, which the narrowband filter would block out. So this is well, broadband is actually a pretty good way to do this. So we'll see what we can get out of it tonight. But yeah, this is sometimes called the tadpoles. And after we get some subs on here, we'll look for the little tadpoles. They're little tiny features inside this overall larger thing. Ray asks how cold it is out here. Actually, well, it's pretty warm. Actually, I can tell you that. I can put my thermometer out here and let it sit for a few minutes and tell you for sure. But it's been pretty warm. We got to like 80 today. It's been in the 70s the last few days. It's supposed to be in the low to mid 80s all week this week. So a bit of an early springing here, and so got some really nice weather. So it's actually fairly warm right now. It's warm, clear, and calm. Kind of the perfect trifecta for astronomy. And I'm dressed warm, but I'm not even having to have things zipped up or anything. It's very comfortable here. It's probably still in the 60s right now out here. So, all right. So we'll let this go for a few minutes on the tadpoles, or Stellarium calls this the letter Y cluster for the star cluster itself, I guess, because it's kind of does this and this and this. So I guess it's kind of the letter Y cluster, and around it is the tadpoles nebula. Oops, wrong screen. Sorry about that. Let's see. According to Wikipedia, this is about 12,400 light years away. This cluster is, and it's embedded in the Tadpole Nebula, which is the star cluster by the Chandra X-ray Observatory. Suggested it contains approximately 4,600 young stellar objects. So this seems to be a bit of a star-forming region where the gases are coalescing into stars and creating new baby stars. I think there's 4,500 or more young stars, or things about to be stars, embedded in this area. Stan says his temperature right now is -7. Feels like -13. Yeah, we've been having some beautiful early spring weather here, so sorry to brag a little bit, but it's pretty nice here. Ray asks what I'm guiding with. The answer is nothing. AM5 with the Hyperstar on, which is only about 390 millimeters of focal length, so not a very big challenge with respect to guiding. It's not a very long focal length, so it doesn't need guiding up to 90 seconds. Stars stay nice and round. When I go to 120 seconds, then I start getting ovals for stars, but up to 90 seconds I don't need to do any guiding, so I'm not guiding with anything tonight. In fact, the picture I showed you of my my setup, that's literally how it still looks. I have not yet mounted a guide scope and camera to it. Although with the upcoming galaxy season, I will be doing that soon, because I'm going to go from... I'm going to take the Hyperstar off the front, and I'm going to start using the back of the scope and put the 6.3 reducer on and start shooting at 1300 millimeters or so of focal length and f6.3, and so that's going to be something that will definitely require some guiding. The telescope's diameter is 8 inches, so it's an 8-inch Celestron Schmidt-Cassegrain telescope. Oh, and I know another thing I want to do here. What do I got? I want to pick up this... yeah, there we go. That's better. Pick up that saturation a little bit. Get a little more color. And hello, Poppy Gloria. So Stan, with the sequencer, was there still something that you needed to screenshot from me, or did my explanation about the tabs make sense? Let me know if there's still something I could clear up. No problem. So, lots of brand new baby stars going on in here. Star forming region. Hey, Jeff. Okay. Yeah, so if you want to see my individual sequences, all right, that's something that I can, yeah, so we can, the two that I use most are this one. So this one here, and you can just come to this spot in my editor. But anyway, if you can screenshot this is the sequence that I use, one of the sequences that I use when I've gotten on an object and now I want to start live stacking. So like I said, this sets the gain of the camera where I want it. These three things reset the sequencer back to neutral, although I think now there's a single command that will reset it without having to do this stuff. Sets the exposure of my camera, and then starts the live stacking, waits 2 seconds, and then clears it from anything that's left in it, and then hides the progress of hides the window when it's done. So this is one that I use very frequently, and another one that I use very frequently is the next target. So this one here. This is the next target. So now when I'm done imaging an object and I'm done live stacking an object, this is the one I now use. Stops the live stacking, sets my exposure to 1 second, because now I'm going to be using plate solving to find the new objects. It maximizes the gain, which in the case of the 183 is 450. It now sets the display histogram to be fairly hard stretched, so I can see better in the display the objects that we're slewing to. Resets the zoom level to 0, so it goes back to full view, because oftentimes I'm zoomed into an object when we're live stacking to look at it. So this resets that to 0, and then again hides the progress window once the sequence is done. So those are really the two kinds of sequences that I use by far the most. One where I'm about to slew to a new object, and once I'm on the object, a sequence to start the live stack itself. So those are the two that I use most. And the rest of them, these are the ones I've used most frequently. The rest of them are just, if I'm using a different gain level for the camera. It's the same exact sequence, but it uses what's called full unity for the 183, or it's just half unity. So half unity I use when I'm broadband, full unity I use when I'm narrowband with the NBZ. And those are the ones these three here are the ones that I use all the time. I got rid of my 676, so these actually aren't even in use anymore. And then these here are what I use when I am using PhD, when I'm actually guiding. Right now I don't need guiding, so these are the sequences I use that don't invoke PhD, because since I'm not guiding. I have different sequences that I use when I am guiding, but they do essentially the same thing, but then they are also stopping and starting PhD automatically. So, but they're all variations on a theme, but that's the basics of it is the two that I just showed you. Hey Mike, welcome. Okay, we got about 10 minutes there. So that is the NGC 1893, or the letter Y cluster. The tadpoles are in here. And I think the tadpoles, they call this a tadpole. Then which things are, I think these little guys here are the tadpoles, which way back when they were looking at it with inferior equipment compared to what we have now, they thought some of these looked like tadpoles swimming around in here, and so it's called the Tadpoles Nebula. Anyway, so cool. There's the tadpoles and the letter Y cluster. So now we'll invoke our thing that goes to the next. We'll get it ready to go to the next object. Okay, so we've done those two. What else have we got here? There's at least one that's already come across. And we got two down here. NGC 1792. Okay. There's that one. So let's go to send the scope to that one. That one's very, very, very low. The scope is pointing almost at my head. So this could be interesting. This could be, and let's get my field of view indicator in here so I can see. Alright, well, yeah, I already have an object right in there, so it looks like we are there. Do a plate solve just to be sure. Yeah, but we are dead center. That's it right there. So now we'll open up our sequence here and start away on that. Okay, and so this is NGC 1792. Which is going to be all the way down here. So interacting galaxies. Transmitter Tombaugh are 41 arc minutes apart and likely had a previous interaction causing high starburst levels currently. Well, I only saw one, but I think I should be able to see 41 arc minutes apart. I should be able to see this only like 2/3 of a degree, so that I should have everything all in one field of view. There's one. Where's the other one? Oh, it's up here. There it is. So according to Stellarium, I should have it. One should be here and one should be here. Well, we're about to find out. Yeah, they're both in there. And look at that beautiful satellite splashing right through the middle. Alright, let's balance the colors, and let's fix the histogram. there are these two galaxies. And I'm going to ignore the satellite because it doesn't really interfere with either object, so ain't no big deal. Boy, and there's another galaxy down here. Oh, we've got at least 3 galaxies in this image. Yeah, right down here there's another one. Cool. Might defocus the same way with a Hyperstar. Yes, the Hyperstar, it focuses using the same focuser knob on the back of the SCT, as if whether you're using the front of the scope or the back of the scope. They both use the same. You're still moving the primary mirror to do the focusing, which is the back of the scope, so you're still using the same knob. I got one of those fine focus wheels for the back of it, just a cheapy $12 or $14, you know, 3D printed part off eBay that just fits right over the knob, and that works great for me. But yes, whether you're using the front of the scope or the back of the scope, the focusing is, you're still moving the primary and doing the focusing exactly the same way. Stan says, what I want to do is go through the marathon, capture 5 of each object at 30 or 60 seconds each, and stack them while on them. Yeah. Yeah, that's a good way to do it. Sequences obviously will significantly speed you up. Again, I think the go-to functionality will do what you want, because the go-to functionality does that. I don't think it would be any slower to use the go-to functionality. I don't know if you're going to be using guiding or not, but yeah, I mean, you can give it a try. I would play with the go-to functionality. Boy, there's another satellite. Well, that one kind of goes almost through. That goes through one of our things, so I am going to unstack this one. The one through the middle, fine, but this one, no go. So yeah, you could play. I would play with the go-to functionality myself, I mean, if you can do that, do it. Refine position you place off recent. Yeah, so you can unselect some of these things which you may not need. Reduce exposure, increase gain during go-to. Yeah, you want that. Refine position using plate solve and resync go-to, which you may not need if you're just making short slews from object to object to object. You may not need to refine every single time, so you may want to uncheck that, which will save some steps in here. But I would seriously try the go-to. Like I said, unless you're doing some sort of overnight pre-programmed sequence where you really need to have you know, complicated sequences that automate your flow. I wouldn't use the sequencer at this point for just regular EAA, which sounds like exactly what you're trying to do. So I would try that out. If not, you can try the sequencer. It's not very difficult to set up what you're going to need. You know, you can use a variation of what I just showed you, and it's not difficult to set up. But I think the go-to functionality pretty much does what you want, and you get that right out of the box with SharpCap Pro. So anyway, here's our 2 little cool galaxies, NGC 1792. Let's see if NGC 1792, doink. Okay, it's a spiral galaxy discovered by Scottish astronomer James Dunlop in 1826. It's about 36.5 million light years away and is receding from us at about 1,200 kilometers per second. It's a spiral galaxy with no central bar, moderately wound arms, and an incomplete ring structure. It has a flocculent appearance with no central bulge. There is a high level of star formation along the spiral arms at distances of more than 3 kiloparsecs from the galactic core, which have led to a number of prominent hydrogen beta regions. A comparable high level of star formation in the nearby 1808 galaxy may indicate a recent distant tidal interaction between the two. And that's why we're looking at both tonight, because they're We think they are probably had some interaction between them. Getting a little galaxy love going on. And so there's a lot of star formation, which is typically caused by highly gravitic interaction between objects. In this case, maybe these two galaxies. As the galaxy appears only slightly disturbed, this interaction mainly impacted the outer parts of the galaxy. So a little over 36 million light years away, and these two probably at some point in time interacted. Yeah, this one down here is real faint. Let's see what let's see if the Galaxy catalog has it. It's PGC 16790 Mag 13. Let's get this bang on. So it's a Mag 13.1 according to the catalog that I've got in SharpCap. So it's PGC. It doesn't have an NGC number, but it has a PGC number. But there's a lot of galaxies in this view. Oh, got another satellite through here. We'll ignore that one too. See a little bit more. Yeah, almost like a couple of long arms spinning off this one too. Yeah, I'm definitely picking some stuff up off here. Whew. I'm actually surprised in this image we haven't seen any airplanes yet. This is very low on my south horizon, and typically from here I see a lot of air traffic from LA headed eastbound down on my low southern horizon, so we may at some point even see a plane go through here if we happen to catch it just right. Probably at the stage where we can zoom in on these a little bit. Yeah, you can kind of see there's a lot more to this that's out there. If it wasn't so low in the soup of my horizon, it might be a bit clearer. But you can definitely see a core and some little bit of structure in here. It looks like some two arms strung off the ends here, but then there's also some other stuff in here too. So maybe there's just some faint rings on the outside. And then this guy. This one's more interesting shaped. I think this was 1808. This is 1808. This one isn't here. Yeah, 1808. Yep. It's a little bit more of an interesting shape, but a little more structure there, not quite as big and spread out. And then our little guy down here, our bonus object, the PGC. Kind of fun. Push the stretch a little bit to get a little bit more out of this one. Make it a little grainy, but definitely a nice little find there. Wonder how far away this one is. It's either really far away or just really small and faint. Probably just really far away though. And this bright spot here is probably either a power wire, power line wire, or telephone pole. So we're just really low on my horizon, and there are power lines right behind me. So cool. Well, there's those two. All right, check. Let's see what's next here. No, not you. There's one right here, Caldwell 73. Or NGC 1851. This will be the lowest object in the whole list, I believe. I don't think there's anything lower than this. So, yeah, there we go. Nice little glob. Okay, we'll do this. And I think because it's a glob, I'll cut the exposure down to... Well, maybe I'll leave it at 60 seconds. Glob 1851 is a possible remnant of a dwarf galaxy. Okay. Possible remnant of a dwarf. Okay. Let's see if there's a Wikipedia 1851. And is a relatively massive globular cluster located in Columba. Astronomer John Dreyer described it as not very bright, but very large, round, well-resolved, and clearly consisting of stars. It is located 40 kilolight years. Kilolight years, I love when they do that. So 40,000 light years away. It's following a highly eccentric... Yeah, see, here's those wires. So unfortunately we're not going to get a great view of this, but yeah, there she is. Back this off a little bit. Won't be quite so blown out. Well, this actually doesn't look very big at all to me, but it looks like definitely a nice tight little glob. That's pretty cool. It has a dense central concentration. It's following a highly eccentric orbit through our galaxy with an eccentricity of about 0.7. So it's orbiting, like most dwarf galaxies, it's orbiting. Well, like all dwarf galaxies, I guess, it's orbiting the center of our... It's one of the Milky Way's satellites, so it's orbiting us. It has a highly eccentric orbit. It has one of the highest concentrations of stars known for galactic globular clusters. NGC 1851 is an estimated 9.2 billion years old, and it's about over 500,000 solar masses. Cluster is surrounded by a diffuse halo of stars that stretches outward to a radius of 240 parsecs. This feature, the halo of stars, if combined with the lack of tidal tail or associated stream of stars, suggests the cluster may be a stripped dwarf galaxy nucleus similar to the Omega Centauri that has been accreted by the Milky Way. The tidal tail is still present, though. It is also possible the cluster is the result of a merger of two separate clusters. But the fact that they would need to have the same metallicity, what astronomers term abundance of elements other than hydrogen and helium, makes this scenario less likely. Anyway, so it's really old, over 9 billion years old again, and the most highly concentrated. So we'll do about 5 on this and move on. We don't have to do a whole lot on the star cluster. You can zoom in a bit, possibly even back the stretch off. Back the stretch off just a little bit, give the core a little bit less blown out. Is that a tiny bright galaxy at the 1 o'clock position? You probably asked that before I zoomed in. Maybe you mean that one? Oh. There's a bunch of them in here. So that one, if that's the one you meant, the answer is yes. So, yeah, when you were zoomed out, yeah, so looks like that one is one, yes. Good eye, Mike. It's a pretty cool cluster. Small and dense, but and there's sub number 5, so I think well, let's see what we got here. So we've done those two. Oh, we had 2188 just come over. So, yeah, we can hop on that one. We can hop on. Those are our southernmost targets. So, yeah, we did good to get those. Southernmost dudes are already there. Got them in the bag. All right, let's see if this will pick 2188. It does. It picks up 2188. Okay, so let's next target, and let's go to 2188, an active galaxy. Even more pointing at my head. All right, let's see. Do I see you in here? I think I do. Let's see. Well, it says it's there. Okay. It says it's 0.07 of a degree, so it's gonna be there. Let's go find it. Okay, so let's see what this. So this one is going to be NGC 2188. Bar-shaped galaxy that had been disturbed by some interaction, possibly with intergalactic gas clouds. For water fields, galaxy cluster Abell 3381 is just 31 arc minutes away, or half a degree. So we may be able to get Abell. We may be able to see a galactic cluster as well. This is interesting. This is me picking up light off something. This is me picking up light off something. Also looks like the mount wasn't quite settled. So this is pointing so low over my head it may be picking up light off something. Not sure what, but something. But it looks like this is, I think, the galaxy in question. We're going to try and reset this. That's a little better. Well, we'll see. Yeah, I'm definitely picking up light off probably either me. It's like pointing right above my head, so I think it's just a little bit too low. It's possible it's also hitting something on the telephone pole or the telephone pole itself. Let's see what a second sub does. It reduces some of the light. There's a very bright star there. That looks like another galaxy there. But if I'm not seeing the galaxy, let's see if there's a galactic cluster somewhere. Not seeing it. There's 2188. There's more galaxies. FGCE. Huh. Galaxy. I'm not seeing any clusters being indicated anywhere in this, but well, this is definitely 2188, even though this looks like another. That looks like another galaxy right there. See if Stellarium has anything about this galactic cluster. Might just be off one edge here or another. I don't see anything indicated though. In any event, and you see 2188. Let's see. A barred spiral galaxy in Tombaugh, located at a distance of about 25 million light years away. It's about 50,000 light years across, discovered by John Herschel in 1836. It's an edge-on spiral galaxy, whose arms are tilted away from us. The only very narrow outer edge of the galaxy's disk visible to us. The galaxy is close enough that its stars can be resolved. The brightest of them had an apparent magnitude of about 21. I didn't realize you could resolve individual stars in galaxies that far away, but when imaged in hydrogen alpha, the galaxy appears asymmetrical, maybe due to a recent interaction. Hydrogen gas is more abundant at one end of the galaxy and extends over 4 kiloparsecs away. Other features visible are some filaments and a superbubble with a diameter of 15 arcseconds. Very small object from my little focal length here, with only 390 millimeters of focal length, but you can definitely see something there. And still, this guy is here too. Hey, good evening, Fantasy. How are you doing tonight? Yeah, I'm glad you had a good time. Yeah, Fantasy came out and saw me at the Death Valley Dark Sky Festival this weekend. I was one of the Las Vegas Astronomical Society astronomers who were putting on the evening star parties Friday and Saturday nights for the Dark Sky Festival. And so I was one of about 20 astronomers, amateur astronomers out there with my gear. And yeah, Ollie came out and said hey. So that was great to meet you. And unfortunately, I didn't have a whole lot of time to chat with you because we had 1,100 people come through on Friday night and 1,200 people come through on Saturday night when you were there. So it was just really busy. There were a lot of people coming through. Some of the lines for some of the scopes were pretty long, which is one of the reasons I like having a screen and doing EAA, because many people can see the image at the same time. So I was able to move people through pretty quickly, showing them the stuff that I had that I was observing that night. So, but it was a fabulous weekend. We had outstanding weather both nights, and so which also led to a lot more people being there from the local area, Vegas and Pahrump and whatnot. So, but there were a lot of out-of-towners too, so out-of-staters. So it it was just a lot of fun. It was a great festival, and look forward to doing it again. A couple of years ago, I think this is the third one that they've had, and the last two in a row have been terrible weather. So this was the first one that was really ago, and it was just fabulous. Both nights were just excellent. It looks like we got a cloud moved through and blocked. My brightness filter ignored that sub, so looks like we got a little bit of a cloud down there. Do you use a projector and screen for public star parties? No, Mike, I don't. I just use my 17-inch laptop screen, and 10, 12 people can crowd around and look over my shoulder. I usually actually sit to the side, and they can look over my shoulder and see what's going on my screen, because I have a 17-inch laptop screen, so it's a pretty big screen, and people don't have any trouble seeing. And maybe one at a time they come up and poke their nose in closer to the screen to see some of the detail, but it allows me to show multiple people simultaneously what I'm going on with, so it works out. I don't really need to use a projector or a bigger screen. Or there are people who have external monitors plugged into their laptops, a 20-inch or 27-inch external monitor that some people will use there. I've never found the need to do that, so I don't know. If I always did big events, maybe I would, but for most of the star parties I don't need to. And of course, this was the biggest one I've ever done. I mean, almost 2,500 people in 2 nights. That's the biggest one I've ever done. So the weather was amazing. I'll need a long sleeve shirt for nighttime, not even a jacket. Yeah, well, that's because you're young and energetic too. Us older folks, we needed some layers. But of course, you were moving around a lot too. When you're sitting still for 3 hours in the dark, even fairly warm temperatures don't feel so warm. Alright, well, we just dropped 3 subs in a row due to, I suspect, clouds down there. But that's okay. I don't know that we're going to get a whole lot more out of this anyway. I'll see if this last sub comes in. But I don't think we're going to get much more than a blob out of this. It's just a bit low on my horizon to be able to see it well. Nope, we're done. Okay. No biggie. No biggie. Alright, so let's see. We got 2207 has now come across. Yeah, we've now got well, we did these two. I guess these two are next. So let's do 2207, and then we'll start just heading up and do those as well. Alright. Let's do next target and head up to that one. Alright. This is another interacting galaxy. Yeah, I can see it right in there. So we'll just start us right off. Go. 2207. Let's see what. Alright, so there's a pair of colliding spiral galaxies about 80 million light years away, so we just jumped a whole bunch of further away, and just got water all over me. So they're very closely interacting spiral galaxies. Discovered by John Herschel in 1835. Huh. Oh, it's interesting. John Herschel discovered them, but only recognized, but didn't actually distinguish that there were 2 galaxies there. So in 1835 he discovered them, but thought it was one galaxy. And then in 1898, Robert Howe actually figured out that there were 2 spiral galaxies here that were in the process of interacting and colliding. So Hopefully we'll be able to see these pretty well. I think we probably will. Oh, right in. That's a power line wire, and that's a power line wire. So we're right in wires. Bummer. Looks like the mount moved a little bit too, so we'll delete this first sub. Yep, we're right in the power lines, it looks like. So this may be a marginal capture. Let's see what happens. Yeah, I still think we'll be able to see it. I was pretty impressed they got that many people to abide by the red light rule. Yeah, the Park Service folks were pretty good at instructing people and monitoring them. So it was very rare to see a white light used, and it was quickly extinguished when it was. It was usually a mistake when a white light was accidentally turned on. So the biggest thing was some people's red lights, even though they were red, were still really bright and blinding anyway. So just because a light is red does not mean it won't be blinding. When you're in the dark, some of those red lights were pretty darn bright. Other than the family with the glow sticks. Don't know what that means. I guess I didn't run into them. What a bummer this is in the wires. You know what, I'm gonna try and do. We're gonna go up and do those other two above and see if we can wait for this to come out of the wires. It's right at the top though too. Bummer. Let's go do these guys here, and then we'll come back and do this one. And IC 443, IC 444. Well, actually, this is probably the best one. Well, let's just get them both. Come on, get them both. This star right there. All right. We'll get them both. We'll give that a few minutes. Maybe it'll come out of the wires. Okay, where are you? Let's get you in there. Oh, we're right near the monkey head. It's always a good one. Oh, okay, this is the jellyfish. Yeah. Okay, so we actually don't want to... No. We don't want to be there. We want to get all the jellyfish. Well, okay, maybe not quite that far. We'll get all the jellyfish and all that one. Okay. Yeah, that's what we want. Alright, let's plate solve on that. And after that has settled for a second, let's get plate solving. So, jellyfish. This one is definitely one that is better with filters. We'll be able to see it, but it's it's definitely better with filters. Jellyfish, one of the better supernova remnants for EAA. Yeah, it's a supernova. Supernova remnant. It's a galactic supernova remnant in the constellation Gemini. And we need... Laptop needs food. Can do that. There you go. It's located near the star Ederonium. Its distance is roughly 5,000 light years from Earth. Yeah, see, and then here is the reflection nebula. That's IC 444. So, Jellyfish is very cool, but definitely helps to use filters because it's got a lot of star field in there. But the filters don't necessarily work well with the reflection nebula, so this way we'll get to see both of them fairly decently. The reflection nebula certainly will come. So this is a nebula that is just reflecting the star of the star that's in it, the light of the star that's in it. So it's basically the same color as the stars. This one here is an emission nebula, which means a nearby star, perhaps Propus up here, this very bright star up here, but perhaps another one, is emitting a ton of ultraviolet radiation, which basically irradiates the gases from this supernova and causes it to glow. So it's also possible the supernova remnant core itself could be doing that, but so anyway, but the point is, this is the two kinds of nebulosity that's here. The emission nebula of the jellyfish and the reflection nebula of IC444 down here. Let's kind of just do that. It may be the remains of a supernova that occurred 30 to 35,000 years ago. The same supernova event likely created the neutron star, CXOU blah 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 blah, the collapsed remnant of the stellar core. IC443 is one of the best studied cases of supernova remnants interacting with surrounding molecular clouds. The estimated distance of 5,000 light years. It corresponds to a physical size roughly of 70 light years across. Which is very, very big. Hey Eli, welcome. How's the weather in New York? Probably pretty snowy, cloudy, and cold right now, based on the satellite imagery I'm seeing. We're looking at the Jellyfish Nebula, and which is IC 443, and IC 444 is this reflection nebula down here. This is a supernova remnant, which happened about 30 or 35,000 light years ago. 35,000 years ago, and it's about 70 light years across. So it's supernovas are just such massive events. It's almost inconceivable. It's 70 light years. I mean, one star has produced a cloud 70 light years of gas and dust in size, and which is just a massive region of space. I mean, 1 light year is basically 800 times the size of our entire solar system. When you look at the orbit of, consider the orbit of Pluto as our solar system. So 800 of our solar systems in 1 light year, and this is 70 light years in size. So just a massive, massive area of space produced by one exploding star. So supernovas are just massive, crazy events. Oh, you're welcome, Stan. I'm glad it helped. And very cloudy. Yep. But actually not that cold. Well, I'm glad to hear it's not that cold. Not that cold here either, but I won't tell you how warm it is. Yeah, Stan is going to do some the Messier Marathon, and so he's wanting to know how to set up sequences for his SharpCap so he can zip through objects as fast as possible. So, well, hopefully either the go-to functionality or some simple sequences will work for you, Stan. Hopefully you'll have decent weather to do it. And 85 on Thursday. Yeah, it's going to be low to mid 80s here pretty much every day this week. So, can't complain about that. We're getting snow. It's been fun with the nephews. Yeah, kids love snow. Going to Hawaii for work. Come on, Mike. Nobody goes to Hawaii to work. That's not why you're going. Maybe the story you're telling people, but I have it all set up in Nina, but Nina doesn't live stack. No, it doesn't. Nina, well, I don't know Nina very well at all, but what I do know is that Nina is really set up for astrophotography. It's designed for people who want to run sequences overnight and program the capture, many hours of capture of an object in one night, and so that is definitely what Nina is best at. But for EAA, SharpCap has the better tools. SharpCap was designed for EAA, Nina was designed for AP. So yeah, for EAA stuff, SharpCap definitely is the one to get. There's obviously a lot of overlap between the two, and as time has gone on and they both added functionality, the lines are blurring between the two a lot. So you can actually fudge and kludge and use either one for either task, but still, Nina is much more ideal for AP and SharpCap for EAA. So that's all I have ever used is SharpCap. I've never used Nina because I'm strictly an EAA guy. So You gotta miss snow. Must get old. So, well, I'll tell you. I grew up in northern New England, in New Hampshire myself, and so I grew up with snow, and I liked snow. Snow was fun when I was young. But I don't miss scraping the car in the morning, and I don't miss having to shovel, and I don't miss having to deal with the drifts and the ice and the... I really, really don't miss it. So, for some strange reason, I just don't miss that stuff at all. And as I've gotten older, I don't miss the cold either. So I'd rather have the heat than the cold as I get older. I never understood when I was young why so many people wintered in Florida and southern parts of the country. But now as I'm getting older, gosh darn it, I seem to be beginning to understand, unfortunately. Can you schedule remote imaging with SharpCap? I don't believe you can, no. No, I don't think you can. You can certainly operate SharpCap remotely, with a VPN or whatever connection, TeamViewer, etc., remote desktop. But to actually program it remotely to do things, I don't think you can do that in SharpCap. That's definitely a Nina thing. Alright, let's stretch this a little bit more. We've got a few more minutes on here. Stretch it out so you guys can really see it better. You can sort of see why they call it the jellyfish. And it is much better with a narrowband filter because it knocks a lot of these stars down. But you can still get a pretty good idea of it right here. We'll go a few extra minutes on it too, just to yeah, Mike brings up a good point. Besides the sequencer, there is also the scripting capability. So you can, and this isn't as a high level, this isn't drag and drop high level coding. This is actually full-on Python scripting that you can use to do stuff. So using that you can do a lot more than I've ever tried to do. So yeah, Mike may be right. There may be something there with the scripting. Hello, Mr. Page Player. Welcome to the broadcast. We're doing the Jellyfish Nebula IC443 and this reflection nebula down here IC444. What did he say? The Jellyfish, one of the better supernova events. Yeah. So, a very pretty thing. We'll go to 15 minutes on this one just because it's a nice object. Got to shut down and get some shut-eye. Thanks as always, Mike. Thank you, Mike, for showing up. See you next time. Yeah, we'll go to about 15 minutes here, and then what are we gonna see next? I think it's 2158's right here. So we'll do that, and then we'll go back down and try and get those cool interacting galaxies, which maybe have dropped out of the wires by now. Hey, one mic goes night-night, and another mic shows up. Good evening, Mike. I'm on the Mac, so Nina and SharpCap are not options for me. Although I have used SharpCap for EAA through parallels. Otherwise, I've been using K-stars. Yeah. Okay. Otherwise, I've been using K-stars. Yeah. Yeah, K-stars is the Linux equivalent to sort of Nina and Stellarium kind of mixed together a little bit. Yeah, there's at one point there was like 4 mics on at one time, including me. So, Hey Mike got a lot of attention. Alright, there's 15 minutes. So, the jellyfish, yay. And I see 444 there as well. So, very cool. Alright, and so now let's go to... no, that one we did. 2158 is next. It's a cluster. Okay. It's a cluster, so let's go over and get that cluster. Alright, yeah, there it is right there. Oh yeah, we got actually a couple interesting things in here. So let's... we got a couple interesting things going on in here. I think I'm going to actually bring this. Let's go center the both of them a little bit better. Yeah, there we go. Now let's do that. I like getting twofers. Image jellyfish myself Saturday night. Yeah, cool. Jellyfish is a really good one. It's much better with my NBZ Nebula dual band filter in it, but even broadband, it's as long as you got pretty dark skies, it still comes out pretty nice. Can you install a Windows emulator to get it to work? Yeah, get a mini PC, but well, Eli's on the Mac platform, so probably doesn't want to deal with anything Windows. Alright, here comes the first sub. Let's see what we got here. Woo! Lots of stars. Way too overstretched for this early in the game. Yeah, a couple of clusters, that's pretty nice. Okay, so NGC 2158, what did you write? Where are we? We're up in the 2158. Very dense, almost globular-like, and lies about 25 arc minutes from M35. May want to try and include both for a nice contrast. Well, so I did. $21.58. $21.68. And then this is that's interesting. There's M35, but then this Karchenko 1. That's interesting. Huh. Well, anyway, M35 and 2158. Two nice little clusters. Very close to each other, too. Parallels has been a good middle ground, though. Yeah. Yeah, a lot of Mac folks just don't even want to go anywhere near Windows. Actually, a lot of Windows folks don't want to go anywhere near Windows either, but for the reasons you mentioned, we have to be here. You know, a lot of stuff runs on Windows, so it's hard to get away from it. For some of the things we do, you just have to end up biting the bullet. Alright, NGC 2158, let's see what we can... It's an open cluster in Gemini, and it's immediately southwest of Messier 35, and it believes to be about 2 billion years old. The two clusters are unrelated, as the subject is around 9,000 light years further away. So, 2158 is 9,000 light years further away than M35. So it's at least, so this is a couple thousand light years away, M35 is, and this is 11 or 12,000 light years away. Once thought to be a globular cluster, it is now known to be an intermediate-age, metal-poor open cluster that is a member of the old thin disk population. The old thin disk population. A thin disk is a structural component of spiral-type galaxies composed of gas stars and dust. It's the main non-center density of such matter. That of the Milky Way is thought to have a scale height of around 1,000 to 1,300 light years, and the vertical axis perpendicular to the disk. Okay, the thin disk. The thick disk. The bulge. Huh. Okay. Thin disk is a structural component of spiral galaxies composed of stars and of the main center. Huh. Okay. It's a member of the old thin disk population. Whatever that means. Anyway. So, both open clusters, but this one's so far away that it almost looks globular-like, but there's no clear, solid core of highly dense stars, so... No, which is what he said. Open cluster is... a lot of software is going cross-platform now. That helps a lot. Yeah, I don't know if SharpCap ever will, but... really no good Mac alternative, yeah. Well, nothing like SharpCap, that's for sure. Well, a couple of very nice open clusters. The nice thing about clusters is you don't have to spend a whole lot of time on them. So, I think we'll just move on and head back to our old friend down here. 2207 and see if he hasn't... No, not 2163. 2207. Yeah, interacting galaxy. Okay. Let's go back and see if it has gone below the wires so we can get a more clean view of it. Again, we go low in the sky. get a better view of those this time. It is a couple of cool looking interacting galaxies that have some pretty nice detail. So hopefully they'll be out of the wires now. We'll find out soon enough. Okay, 80 million light years away. Discovered it, well, sort of two different times. Now it's right in the wires. Well, unfortunately, this is just the way it's going to be tonight, so we'll have to get as best we can with what we've got here, but unfortunately it's right directly in wires for me, so... Bummer. You know what? That's terrible. That's terrible. We're going to come back. We'll have to come back to it. Okay. Let's see. The Dolphin Head. The Dolphin Head. This is definitely a challenging object to do. It's a very beautiful but very faint object. Very beautiful but very faint object. And so what I'm going to end up doing here tonight is I'm going to cheat. It's also much better done, well, it's much better done with a filter because again it knocks the star field down. But because it's so faint, the filter also restricts its light to some degree. So it's yeah, it's a little bit of a tough one. But we're gonna cheat tonight because, ironically enough, I did this last night when I was broadcasting on NSN. So I spent over an hour on it with the Nebula filter. So we're gonna spend a little time resolving it here. We'll spend maybe 10 minutes or so resolving it here, but then I will cheat and pull up my result from last night, so you'll be able to see what it looks like when you get to spend some time on it. 2-308, the Dolphin Head Emission Nebula. It's about 4,500 light years away, and, well, about 5,000 light years away. Let's see. And it's created by something called a Wolf-Rayet star, which is a star that's in pre-supernova stage. So at some point soon in stellar time, not human time, but at some point soon, it's going to go supernova. Well, you can just barely see the outline of it here. Well, we'll see what we can get in a few minutes here, but the stars are so, the star field is so dense that it's very tough to bring out without filters. But we'll capture a few subs and see where we get to. Anyway, it's about 5,000 light years away. I think it's about 60 light years across. Yeah, 60 light years across at its widest point. So, like the jellyfish that's 70 light years across after the explosion, this one hasn't exploded yet. It's blowing off outer layers before it explodes, and these are almost as big as 60 light years across. So it's definitely blowing things out. We'll see what we'll try getting about 5 minutes on this and see if we can actually resolve much better. You can see the faint outline of it here, but honestly, without filters and this thick star field, it's a tough thing to get. So that last sub was me standing up accidentally. Well, I didn't stand up accidentally, but I stood up in front of the telescope with my red headlamp on. So I had to get rid of that sub. Thank goodness for the unstack button that has been added into SharpCap, which will allow you to unstack the last sub put on the stack. So if you get an error like that, you know, a light shines all of a sudden, or a satellite blazes through, you don't lose the whole stack. You can just unstack the last sub and just keep going from that point forward. So we were after Robin for years to get that added, and he finally did about several months ago. And what a godsend it is, especially with all the satellites that are in the sky these days. Speaking of which, there's one right there. And you know what? I don't think I even care, because we're not going to be able to see a whole lot out of this anyway. This really requires filters. So I'm going to, while that's continuing to roll along, I am going to bring up the the thing from last night. Dolphin head, dolphin head. Let's look at that juicy little image. Alright. So, yeah, this is just really faint. Anyway, so here is what I got last night. But this took over an hour of integration time, and I have it stretched pretty hard here, so it's a little bit noisy. But it knocks the star field back enough for the nebulosity to really come forward. And so this is what I got last night. I took 43 90-second subs. So, you know, over an hour, well over an hour of... that's what, 65 minutes or something worth of integration time to get that. But this is what I did last night, and so we'll just pretend I just did it now, and we did a time lapse, and you guys didn't have to sit through all of that. But it's quite a beautiful nebula, and the Wolf-Rayet star, which I assume is this one, is the one that's producing all this. It has not gone supernova yet. It will at some point soon, but in the meantime it's blowing off all these outer layers, and irradiating them as it does so. So it's making it glow into this beautiful, beautiful image. So anyway, we'll pretend I did it tonight instead of last night, but this is what ultimately it does look like when you can spend some time on it with some good filters. But in any event, we'll just say goodnight to the rest of this, though. All right. So. Alright, now this one I believe is... Yeah, this one I believe is the Tombaugh objects, which Stellarium doesn't have a clue about. So, I had to fake it on a couple of other stars, because it doesn't... Stellarium does not have the Tombaugh objects, these two Tombaugh objects, in its catalogs, so I just had to kind of fake it here, so let's get this started, and we'll see what he has to say about these. Tombaugh 1 and 2 open clusters. And Canis and Majoris. Tombaugh 1 and 2 cataloged by the discoverer of Pluto make a nice contrast in open clusters, like a minor version of NGC 2158 and M35, which we've already just seen. Okay, so let's see what they look like. Thanks, guys. Yeah, the Dolphin head is a beautiful, beautiful nebula, but it takes filters and time. So it's almost strictly an astrophotography. It's an astrophotography object. It's really not an EAA object. I think if you're spending an hour on something, it's probably that's kind of pushing the limits for what I would consider EAA, but it's such a beautiful object that I love it. I love it. Oh, you know what? I'll bet you this is one and this is the other, isn't it? Let's see what... yeah, see, oh, there's a Tombaugh down here. Where's the other one? Okay, Tombaugh, open cluster. Okay, that's Tombaugh 1, and this is Tombaugh 2 down here. Okay, yeah. So, off by just a little bit. But I think it's enough. We can just pretend that we made them both. Because there they both are. Right there into view. And you can see how close we are to those stupid wires. Going right there, but at least these are off our object. We'll try and come back to that galaxy a bit later. Hopefully it'll drop down out of those wires, because it does look like we will be able to see some pretty nice detail from those two interacting galaxies. So I'm still hoping to get those. Still hoping to get those guys. Which is, what, 2207? Yeah, 2207. So we'll just wait until it drops down a little bit further. Meantime, we'll buzz around and get our other objects. Let's see what else is good. We got anything else that's crossed? We've done 443 and Trouble Fund 4. So we've got these two that have just crossed. This one's about to cross. We've done these already. We did this one already. So we're kind of buzzing along here. We got these three left to do yet. One is crossed already, one not quite. I think we've done the rest. Yeah. So we've got 4, I think, left before we head back and try to get our 2207. Okie dokie. Okie dokie. Tombaugh 1 and 2. feels less dense and almost harder to pick out. Alright, we'll finish up this sub and move on to the next thing. Tombaugh 1 and 2 in the bag. Alright, what's next? Caldwell 58 just crossed, so let's do that one. Caroline's cluster. Did I? I didn't stop the stack yet. Alright. Head to Caroline's cluster. And there it is. So this no doubt named for Carolyn Herschel. Oh. Thanks for coming, Ollie, and thank you for I'm very glad you came and showed up on Saturday night. It was great to meet you, and yeah, I'll see you next time, whenever. Drive safe getting home. All right, this is what 2360. Discovered in 1883 and 1783 by Carolyn Herschel, who described it as Caroline, who described it as a beautiful cluster of pretty compressed stars near 1/2 degree in diameter. Her notes were overlooked until her brother William included the cluster in his 1786 catalog of 1,000 clusters and nebulae and acknowledged her as the discoverer. Well, that's not exactly atypical for the time. And, well, I don't know. Hopefully things have gotten better these days, but yeah, she was overlooked because she was a woman. Anyway, as a combined apparent magnitude of 7.2. American astronomer Olin Eggins surveyed the cluster in 1968, concluding that the brightest star in the field, which is a Mag 9 star, is likely to lie in the field and not a true member of the cluster. Is likely to lie in the field and not actually be a true member of the cluster. The age of the cluster is a little over 2 billion years. It has a diameter of 15 light years and is located 3,700 light years from Earth. adjust this? Not really. Back it down a little bit. Just a bright blinding bunch of stars otherwise. Oh, I just realized all the thumbs up. Thanks for all the thumbs up, guys. Appreciate the love. Just noticed all those thumbs up there, so thank you, thank you. Okay, so while we're working on Caroline's Rose, what else have we got going? We got these three up here, I believe, and the one in 2207. Those three up there in 2207. Well, we'll do one more sub. Definitely don't need to spend a lot of time on clusters. There's quite a few little stars in there. But, you know, that's thanks to our modern equipment. If you probably, to see it the way she saw it, probably would look something a lot more like that, maybe, what she saw. You know, back in the 18th century, there was a lot more. Glass wasn't all that great, and they certainly didn't have photography back then, so they couldn't do exposures. So, you know, what she could see was probably maybe something like this, maybe not even as good as this. So, good for her for finding it. Meanwhile, we get to put our long exposure, highly sensitive digital cameras on it and take this kind of stuff. So, very cool. Okay. Well, we just finished the 6 subs, so we'll just stick it in there and say yay. Good stuff. Even some multicolored stuff is in there. I think the brightest star is here. This is probably the brightest one. It's the one that actually they think now is not even in the cluster. Alright. Next. Next. Let's go up and hit NGC 2341. Well, that's 2342, which I have a feeling is probably... Yeah, well, it'll be close enough, that's for sure. It'll be close enough for gummit work. Okay, let's plate solve on that to make sure that, yeah, we're right there. Okay. Give that a couple of seconds to settle, and then get her started. Okay, 2341. there's a spiral galaxy in Gemini. Yeah, 21, 43, 42. It's about 260 million light years away. Together with NGC 2341, forms a gravitationally bound galaxy pair. Ooh, he's looking very small. Very small. Very, very small. Very, very small. Yeah, we are going to be hard pressed to pick out much of these. This really wants more focal length. Yeah, 42, and this most probably is 41 there. 42 and 41, yeah. Yep, there they are. 260 million light years away, thus they're so small. We'll get a few subs here and then see if we can't pull out some more details. But these guys are very small, a little too small for my short focal length here. But we can kind of see there's a little detail in this. I'm really curious to be able to get those two that are down south of 2207, C2207, because those look like we were really going to be able to resolve some detail in those. So I'm hoping in a little bit they'll be dropped below those wires, those power wires, and will be accessible. We'll do 2371, and we'll do 274, and then we'll head down to that one. Because we've done everything else. Yep. Done everything else, I believe. We did do 2149, right? Pretty sure I did. Ooh, you know what? We didn't do 2149. That's a planetary. How big is that sucker? 22, 15. Small. What is this? Whoa. It's a planetary nebula that's significantly smaller than these two. I may just skip it. Yeah. We're here, we'll go look. We'll go look. But that's even smaller than this. Even small, it's about half the size of this, so it's very, very small. We'll go see if we can see anything. Eli, the focal length of my setup is about 390 millimeters. So a little less than 400 millimeters of focal length. So it's not good at zooming in on small objects too much. This is about the extent. Actually, this is more zooming than I normally do. I think I just got some good seeing tonight, but normally it's pretty grainy past about a 50% zoom factor, and I'm at 90 right now. So it's really it's fast wide field. So it's designed to get big faint objects pretty well, like the Dolphin head, etc. And so it's not really good at doing the tiny stuff. So here in the next couple of weeks, when the moon comes back out, my project for this hiatus between the dark sky periods is going to be to mount the guide scope and camera on the C8 here, and put the 6.3, take the Hyperstar off and put the 6.3 reducer on and get ready for galaxy season. And with the 6.3 reducer, I'll be right around 1300 millimeters of focal length or so, which will be much better at getting these kinds of small, little tiny objects. It won't be very good at getting faint objects anymore because it's much slower, but it'll be about perfect for galaxy season. But with the Hyperstar, we're a little under 400 millimeters of focal length, so good for fast wide field. So we're getting some fairly decent detail with this. Let's do one last histogram adjustment. Kind of even back this off a little bit. See if we can pick a little bit more detail off. And this galaxy here definitely got some swirlies going on. Got a core there. Got some swirly arms going on here. So almost looks like an earwig or something kind of shape, but yeah, well, I'm kind of amazed at what I'm getting to. Like I said, it must be a night of decent seeing, because this is definitely way further than I normally zoom in on anything. Further. Probably even just unstack a little bit there. Maybe not unstack, but just back the stretch off just a little bit, darken a little bit, give you a little bit more detail on that object. But yeah, it's pretty darn good. This one here doesn't seem to have much of, I don't know, it's hard to tell from background stars, or actually foreground stars in this case, what's galaxy and what's not. I don't have enough focal length to resolve that, but definitely see the bigger one pretty well. And that satellite goes right through it. Well, we're done anyway, so anyway, so there's those two guys. Alright, so now let's get, well, I said we'd try this planetary, 2149. Let's go ahead and take a quick look at this. I think it's going to be way too small, but we'll see. Centered on it. Yeah, we are. Okay. Put that real quick. quick. We'll do this and see if we can. This one's definitely going to require some zooming in if we can pick anything off at all. But we shall see. C2149, discovered in 1906 by Wilhelmina Fleming. Oh, nice. It's a small, bright planetary nebula with something to offer in telescopes of most sizes. Really? Assumed that was it, but now I'm not so sure. Thing is so small that it's going to be probably indistinguishable from a star. Where is it? That? That doesn't look anything like the picture. Huh. With something to offer in telescopes of most sizes. Apparent size of 12 arcseconds, and like other objects of its class, a nebula filter may help in its observation. Its distance is about 3,600 light years. Huh. I'm not seeing anything. I think we're just seeing the central star and that's it. Yeah, I think maybe it's going to require a filter, I guess. I'm not sure. I mean, I don't see anything but a star there. The catalog clearly indicates it's there. I don't see it. Does Stellarium? I probably didn't even have a picture of it. Well, Stellarium sees exactly what I see. A star. But the Wikipedia clearly has a star with a cloud around it. There's an apparent magnitude of 10.6 and an apparent size of 12 arcseconds. Huh. Well, I'm not seeing anything. So I think this object was a fail. I've got to do this just to confirm it. 2149 Planetary Nebula Mag 1078. Yeah, it looks like a Mag 10.78 star to me. Huh. Yeah, that's no doubt about it. Well, looks like we just don't get to see anything on this one. This one's a fail. So They are saying it's in near infrared. A nebula filter may help on its observation. The near IR image is pretty nice, but I'm wondering if my UV-IR filter is blocking it. In any event, we're not going to waste more time on it. We're not going to waste any more time on it because it's just my setup is not going to be able to get it. So let's see, 2371, the Gemini Nebula. Okay, Gemini Nebula. We did 2341 and 2, so now we got this one, and then 2207. Okay. Well, we've been dead on with the other ones. Let's just not even bother to plate solve. Because we should be dead on with this one too. And this is 2371. And Tool. Dual-lobed planetary nebula located in Gemini. Visually, it appears like it could be two separate objects, therefore two entries were given to the nebula by John Lewis Emil Dreyer in the NGC, so it may be referred to as 2371 and 2372, or variations on this name. It has also been called the Double Bubble Nebula. Central star of the planetary has a spectral type WO1, indicating a spectrum similar to that of an oxygen-rich Wolf-Rayet star. So it could be a Wolf-Rayet, which means it's in, like the Dolphin Head Nebula and Thor's Helmet, it's a star in pre-supernova phase. Alright, let's buzz on in there and see what we can see. We definitely see something this time. Yeah, it's like it's got this part and then this part. It's almost got like two layers. And that's pretty accurate to the image I'm seeing in Wikipedia too. So give this a few subs and see if we can pull out any detail. Hey Mark, welcome to the broadcast. Yeah, well, I suppose we could try Leo 1 after I get get these other things done. I only got a couple more to do here, so we could try Leo 1 after that. Oh, didn't he come on? Yeah, I did. Didn't have the time to go over and look, so yeah, I didn't even look to see if he was on or not. He threatened last night that he was going to be. I guess he didn't. Oh, you know what I didn't do? Well, his observatory just frustrated him enough tonight to say the heck with it. Well, we're obviously zoomed in way further than we should be with this, but you can see a little bit of detail back off the stretch a little bit. You can see the central star in here, sort of this core region. We lose the outer bits, but we see the inner bits better. Take one more sub here. The outer parts could certainly use more time, but the inner parts are... The outer parts want more stretching to see all of those. See sort of the wispiness here, but then it blows out the inner parts. That we want less stretch to see that core structure a little bit better. But the main sequence star in its death process. Coolies. Okay. NGC 2371. Okay, and then next we've got sharpless. 2274. Oh, the Medusa, yes. The Medusa. Alright. Did I? Yes, you did. Yeah, again, we're probably going to be pretty much right on it, so let's just go. No plate solve required. What are we on? The Medusa. Abell 21, he's calling it. Is brighter than most Abell planetaries. It emits mostly in hydrogen alpha. Yeah. Okay. Well, which in other words, it would be better off with 2274. SH2274 Medusa Nebula. There's a planetary nebula in the constellation Gemini, originally discovered in 1955 by University of California UCLA astronomer George O. Abell. Oh, look at this one. This is actually a really nice size. Huh. This one's downright reasonable. We classified it as an old planetary nebula. With the computation of expansion velocities and the thermal character of the radio emissions, Soviet astronomers in 1971 concluded that it was most likely a planetary nebula. As the nebula is so large, its surface brightness is very low, with surface magnitudes between 16 and plus 25 reported. Whoa. Yeah, there's a lot more to this. It's actually, there is quite a bit out here, and there's quite a bit up here too, actually. Well, we'll have to see what we can collect out of this. But we'll spend a little time on this, see how much of it we can get. But there's actually a lot more to this. This is just the brightest part. There's a lot more to this. It's actually a fairly decent size around it. Let it get a few stacks and then see. We'll get several subs on here, and then we'll see if we can pick out some. Stretch it enough to get some of the outer detail. art is certainly pretty. The rest of it is probably going to be like the Dolphin head. And shy about stepping forward. We'll need to take some filters and some time to really come out. Pretty though. From what I can see, it is a pretty looking little nebula. Yeah, and I'm also able to zoom in a lot further tonight and not have things fall apart. Like normally I can't zoom in more than about 40% or so. Tonight I've been able to zoom in a lot further for whatever reason. I don't know if I'm just having good seeing or what's going on, but tonight the images are coming out somewhat cleaner. Maybe the sensor's having a good night. It's a pretty one, but according to the Hubble image, there's a lot more to it here, but the rest of it is really faint stuff. But the part we can see is pretty nice. I'll take 12 on this one. A couple extra minutes. I think it's worthy of that. So we got, okay, so we've done all those, just so we've done that one, we've done this one. Okay, so all we got is 2270 now. 2207, excuse me. 2207, which hopefully is out of the wires at this point. Cool. All right. Well, let's go. Let's go see if 2207 is in 2207 is in the clear. Let's go see if it's in the clear. Everything else we've already gotten. This one is the last one. Let's make sure we are on it. Okay, just a small correction. And let's go to it. See these. No, the power lines wires were basically blocking the object when we've been on it the last couple times. I've tried it already a couple times this evening, and both times the wires, because this is low on my southern horizon, so I'm shooting right through power lines, and both times the wires have been like right over the object. So figured I'd go do do the rest of the objects and come back and hope that it has now that it's gotten lower in the skies dropped down out of the height of those wires. Well, we'll see here in a few seconds. Alright. That. Yeah, you can still see they're kind of here a little bit, but this should now be dropping below them, I think. Anyway, last time they were right in these wires, and now it looks like they've dropped below it, so we should be able to get some decent shots of this now. Looks like the stars are a little streaky. I think I want to clear this and start over again. Mountain may not have completely settled. For that first sub. Yeah, these look better. Nice satellite blazing right through, but thankfully it's not going to intersect our object, so don't care. But this is a couple of very cool interacting galaxies. What did we say they were? 70 million? 60 million light years away? No, closer to 100 million. Okay, so about 80 million light years away, plus or minus a bunch. So, about 80 million light years away. It's an intermediate. The larger spiral, this one here on top for us, is an intermediate spiral galaxy exhibiting a weak inner structure around the central bar. The smaller companion spiral is a barred spiral that also exhibits a weak inner ring and an elongated spiral arm that is likely being stretched by tidal forces with the larger companion. Both galaxies contain a vast amount of dust and gas and are beginning to exhibit enhanced rates of star formation. The two are in the process of colliding and merging, but unlike the antennae or mice galaxies, they are still two separate spiral galaxies. They're only in the first step of colliding and merging, with the larger galaxy being in the process of tidally stripping the smaller one. Soon they will collide, probably looking a bit more like the mice galaxies. In about 1 billion years' time, they're expected to merge and become an elliptical galaxy or perhaps a disk galaxy. I don't know. Can't tell. Now this is looking... I can't tell what this is doing. Anyway, well, we're going to go with this now. I can't tell if this is impinging on the object or leaving the object or what, but... I think it's still partly in the wires, but... Can't tell for sure. Hey, Cam. Thanks for joining. We are definitely having some beautiful weather out here, that's for sure. So this is a pair of interacting galaxies in here. And Mark said, look, a SN on the left. SN. I don't know what SN means. A supernova on left. Don't know what that means. Are you saying there's a supernova somewhere in here? I think it would be bigger and brighter if it was. A supernova in the Milky Way would be very bright. Unless you're saying that's a supernova. That's most probably a foreground star. Well, at the risk of making things a bit grainy, we'll zoom in a little more. Try and separate these two. Barred spiral of this one and there's the barred spiral of that one. Definitely see the arms of this one as these two things collide and merge together over the next billion or so years. Oh, so you're saying maybe this one? Well, I suppose it's possible. Could be an area just of bright, intense star formation, but I have a feeling it's probably like one of these. It's probably these are this one, this one, this one. They're foreground Milky Way stars, most probably. Now with that said, there's probably going to be, oh, look at a satellite blaze right through there. Yeah, it's faint enough, doesn't matter. Now with that said, with these things colliding, star formation is probably going nuts in these galaxies with all the gravitic interaction that's happening, so who knows. There could be some exciting stuff happening. It's possible. We'll take a couple extra subs here since we're zoomed in so far. I think that is our last object from, yeah, that's our last object from the challenge. But then Mark gave us another object, and he's going to make me flip all the way over the horizon, over the meridian, and come back to Regulus to get. Need to look at someone's older pic. Sure. Go find one and post a link. Well, I guess you can't. If we were on NSN, you could post a link, but you can't post links on YouTube. They won't let you do that. that because I've got the, yeah, you know, I'm looking at the HST's image, and yeah, it's got to be a foreground star. Well, the HST's image doesn't seem to indicate much of anything there, but you know, it makes all the foreground stars really, really tiny. Let me see if I can open this. Yeah, there's a bigger image of it. Yeah, see, there's quite a few foreground stars in there on that left-hand side of the, you know, in here. It's quite a few foreground stars in there. So, I don't know. Could be a supernova, could be a foreground star. Who knows? Oh, the name of this? This would be NGC 2207. So, there's a nice HST image in Wikipedia, if you want to go look at that. But you know, I can't really tell. It could be an area just of star formation. Could be one of the foreground stars. I don't know. In any event, there's that object. So that's the end of the challenge. So now Mark wanted me to go try Regulus 1 or Leo 1, whatever it's called. The dwarf galaxy, right next to Regulus. The dwarf Leo 1. Duh. Okay, Leo 1. Alright, to do that I'm going to have to go flipping all the way around the meridian and coming back, so I'll kick that off. Okay. Hello, random. Alright, so let's see if we can pick it up. Now, I have a feeling I'm not going to want to be there. I'm going to want to try and get Regulus out of the picture. So let's pick some stars that might do that. Almost. Yeah, let's try and keep Regulus just a little bit out of the picture. Maybe we'll go even a little more. Yeah, we'll try that. Okay. Let's see if that works. Get that little star there. That was a long slew, so we'll plate solve to see how close I am. last night. I tried this when I was broadcasting on NSN, but I had a galaxy filter in, so that's interesting. What the heck is that? I had a galaxy filter in, so it didn't do so great a job. It kind of knocked a lot of the light down. What the heck is this? What the heck is this? Something in here. That's a pretty wild deal. I don't know what that is. Anyway. Leo 1. The Leo dwarf galaxy. Let's see if we can take a few subs on this and see if we can resolve anything other than a puff of light. A little bit more information about this. It's a dwarf spheroidal galaxy about 820,000 light years distant. It's a member of the local group of galaxies and is thought to be one of the most distant satellites of the Milky Way. It was discovered in 1950 by Albert George Wilson on photographic plates at Palomar on the 48-inch Schmidt camera. It's located only 12 arc minutes from Regulus, the brightest star in the constellation. For that reason, the galaxy is sometimes called the Regulus dwarf. Scattered light from the star makes studying the galaxy more difficult, and it was not until the 1990s that it was detected visually. The proximity of Regulus and the low surface brightness make it a real challenge to observe. Medium-sized amateur telescopes and a dark sky appear to be required for a sighting. But some reports of April 2013 tell that one observer with an 11-centimeter mini Dobsonian and even a refractor as small as 7 centimeters has sighted Leo 1 under very dark skies. Seems to be certain the galaxy does not rotate. A kinematic study could not place much constraint on dark matter, but suggested the presence of a black hole of 3 million solar masses in the center of the galaxy. This would be significant, as it would be the first time this has been done with a dwarf spheroidal galaxy. A black hole of 3 million solar masses is comparable to the mass of the Milky Way's black hole, Sagittarius A. However, another study could not confirm this, suggesting at most an intermediate mass black hole of a few tens of thousands of solar masses. It has been suggested that Leo 1 is a tidal debris stream in the outer halo of the Milky Way. But that hypothesis has not been confirmed. Yeah, I guess. I don't know that I've ever seen any decent pictures of it, but actually what's more interesting to me is whatever this is. The heck is that? Gonna have to go investigate that after. We'll do 10 subs on this, then we'll go over and see that. No, I don't save any of my images. I mean, I can, but I'll save this. When we get to the 10th sub, I'll save this one. Guess I should name it. Name it Leo 1. Alright. We'll save that. Now. I'm going to move this thing over to here. Pixel position and recenter. Yes. Move. And now restart. And restart. And we'll clear it here when it gets there. But this is just really weird. I wonder if it was just a one-time thing. Well, we'll find out. Definitely an interesting looking deal. Find out in a second here. And there's nothing there. Oh wait. Yeah, there's nothing there. That was just some sort of one-time weirdness. Huh. I wonder what the heck that was. Well, that was pretty weird. Whatever it was, it would look like a one-time thing. Because it's not in any of this. Not in any of this. Wow. I'm right here. Why would I not do a sneak preview of galaxy season? Why would I not do a sneak preview of galaxy season, like right now? Because I'm already right here. Well, whatever that was, it must have been a one-time camera weirdness or something. Maybe it was a spaceship. Maybe it was aliens playing around in the sky. Yeah, reflection off the camera, who knows. Come on. Yeah, okay, let's get you to the middle, please. And we'll do... This will be the last thing I do. I should go in now, but I'm right here. Sneak preview of the next few months. Sneak preview of galaxy season. Coming up. Like I said, I'm gonna... As soon as the moon comes out here again in another week or 10 days, I'll be pulling the Hyperstar off and putting the 6.3 reducer on the back, and the camera on the back of the scope, and mounting the guide scope and camera, and getting ready for galaxy season to do some longer focal length stuff. I'm really surprised how far I've been able to zoom in on things tonight, but I don't expect that will be a ongoing thing. I suspect that I will to get all the little galaxies I want to really have some focal length going on. But there's these three. The Leo Trio. In all their glorio. bonus objects. Well, yeah, pretty cool. So, looks like my internet might have just dropped a bit there, but thanks everyone for being here. It was a good list that Steve put together. And so, yeah, really appreciate everyone being here. And if you stuck it out this long, thanks for watching. And I'll see you next time. I don't know if there'll be another night in this Dark of the Moon that I'll be able to get out here again, but might be within the next few days. Who knows? In the meantime, everybody take it easy, and I will see you next time.